Hi dear students and viewers, welcome back to our channel N1A Kumar Basics of Physics. Dear students, in this video we are going to discuss about the one activity that will use the relation between the resistance and nature of the material. So very important one and very easiest one to understand. It may ask for 4 marks question in the public examinations. That's why watch very carefully. The first thing is, what is resistance? When the current is passing through any particular conductor, the conductor will shows the opposition to the flow of electrons. That nature of the conductor is called resistance. The opposition shown by the conductor to the flow of current is called resistance. So already children, we discussed in the previous videos the relation between the different factors and resistance. So what it is? Resistance is directly proportional to the length and inversely proportional to the area of cross section. R is proportional to 1 by A and R is proportional to L. And from those two, what right? R is proportional to L by A and R is equals to rho into L by A, where rho is what we call specific resistance or resistivity. So children, so this is simply about the what is resistance and what is the formula for resistance and what is the formula for specific resistance. Rho is equals to RA by L, and in the previous video already we discussed about all these things. Now children, activity to explain the resistance depend upon the nature of the material. So to do this, we have to take the different type of wires which are made up of different type of materials. Clear? So I wrote here some materials like silver, aluminum, iron, nichrome and copper, tungsten, like that. So we are taking different types of wires made up of different type of materials. Clear? To do this activity, you have to maintain length and area of cross section both are constant. Here, to do this activity, we have to maintain length and area of cross section both are constant. That means we have to take the same length of wires and we have to take the same area of cross section of wires. So when obviously what we know, R is equals to rho into L by A. What we are saying, to do this activity we have to maintain same length and same area. That means what? Rho is equals to R. So we are explaining the relation of among the resistance and specific resistance. So children, so this is simply the first thing. What it is? To do this activity, we have to take the different material. That means we have to take the different wires of equal length and equal area of cross section. Clear? Now children, for different wires we have different resistivity values are there here. For silver, for aluminum, for silver is what? 1.59, aluminum 2.82, iron 1.00, nichrome 1.10, copper 1.68, tungsten 5.60, like that. So for different wires they have different resistances. Clear? Why we are taken different type of material means different type of materials have different resistances. When they have different resistances, they can sense the different amount of current. That is that you have to prove, and we have to do one activity to prove that. Clear? So the first thing is, the experimental arrangement should be like this here. So in diagram you are finding some symbols. So it is the now. So here P it is there, QD is there. Here P and Q are the ends of the wires. Now this is the battery and it is the ammeter and this is the plug key. So we have to construct a simple circuit. We have to connect the battery minus to the ammeter to the plug key to the one more wire. By using soldering rod we have to connect them, and battery plus to the another end of the wire. So in between B and Q we have to insert the different type of materials and we have to check the how much current is going in the ammeter. So what is the purpose of battery? Battery can supply the charge or potential, and A means what? It will find out the how much current in the circuit, that is the ammeter. And plug key is what? When key is open, the circuit is said to be open circuit. When key is closed, the circuit is said to be closed circuit, and that is the current. Clear? Now in this case it is the open circuit. Clear, children? Now here we have to take the first one type of material, and for example here now the first thing is here we are taking some silver. First silver wire it is there, that should be connected in between these two. First one is what? So we have to take the one tabular form, serial number, and material made up of which type of material, and current in the ammeter. Clear? First thing is what? Material, and this is the what? Current in the ammeter. So first what we are taken? Silver wire we are taken. When silver wire we are taken, and that should be given in between the P and Q. After that key is closed. Then it is the now closed circuit, and the current is moving from higher potential to the lower potential in the circuit. Then you have to identify the how much current it is in the ammeter. That's the value you have to note here. And next we have to take the another wire. So we have to remove the again keys, have to open, and after that you have to take out the silver, and you have to take the now aluminum. So in the same place we are going to insert the now here aluminum wire. Then again you have to check how much reading in the ammeter. So first we are taking silver, next aluminum, next remaining all we have to check it. So by changing the particular wire, we have to observe the how much current is shown in the ammeter. So according to this activity, you have to check for every material we are getting the same resistance or different value. Clear? For every material we are getting the same value for current in the ammeter or not, you have to check it. Clear? Then what you have to say? For example, all the materials are gives the one constant amount of current. Then what you have to say? Resistance is independent of material, you have to conclude. Clear? While we are repeating the same procedure by using the different type of wires, if we can get the same type of current in the ammeter, then what we have to conclude? We have to conclude that the resistance is independent of the material, nature of the material. But children, in this activity we never get same amount of current in the ammeter. Why? Because all of you know what we know, V is equals to IR. So from that what we are taken? We are taken the battery is the having some potential V. So this is the constant. Then what to write? I is proportional to 1 by R, or R is proportional to 1 by I. So I is proportional to 1 by R. So simply what you have to say? There is some inversely proportionality between the resistance and current. When the resistance is more, current is less. Clear? When the resistance is less, current is more. That means, for example, you have to understand that I gave some values of resistance here. For example, when we are using the some silver wire and here tungsten wire we are used. Clear? Silver and tungsten. Among these two, so for the tungsten we will get the very least value in the ammeter. Because of what? It has more resistance it is there. Clear? So children, these are the values for resistivity, and resistivity nothing but it is what? Resistance when L and A is equals to 1. Clear? That's why here by taking the resistivity values I am saying that here when we are taking silver and tungsten, among these two, tungsten has more resistance, when the particular type of tungsten is used in the material, ammeter will shows the very least value of current. And if you can take some iron, it is having very least resistance, then the reading shown by the ammeter while we are using the iron here, the ammeter will shows the more current. So that means what you have to say, in that activity you have to conclude that when the material changes, the value shown by the ammeter also changes. What it means, we are changing only the material, we are not changing the battery, we are not changing the ammeter, and we are not changing the plug key, and remaining wires also same. But what we are changing, only in the material, the wire what we are taking different type of wires, we are going to change them. When they are replaced by one by one, then the values are going to be changed. That means that what you have to say, when we are changing the wire, the reading shown by the ammeter also changes. So in ammeter, the current value is showing more, means the resistance of the material what we use, that is the least value. When the ammeter is showing the least value, then the value of resistance what you are using, that is the maximum value. That's why what you have to say, from this activity we can conclude that the resistance is depend upon the nature of the material. Nature of the material means what? By which material it was prepared, by using what, that's the decides the nature. Clear? So that's why what you have to say, when different materials are we can use, we are getting the different resistance values, due to that we are getting different current values. So children, from this activity what you have to conclude, resistance is depend upon the nature of the material. So in the coming videos we will discuss about the what is the relation between the resistance and length, how we can prove it. So let's wait for that. So if you can understand this one children, just like, share, comment the video, and if any of your friends are required like subject like this, please suggest my channel to them also. Thank you for watching.